Okay, we are going to open the software, Staad Pro V8i. Then in this options, we are new project we are started. No, that's why selecting new project and plane structures and meters. Length in it is considered as meter and force unit is in kilonewton. Then after selecting these two, then click on next, and it is asking this file is already exist. So we are going to define first. File structure 1 is there, so we are selecting the cantilever member. Okay, canti, I'm going to file name is given and click on next. Then here add beams, we are selecting the beams, not a this is a plane structures, no, that are continuous beam, right? That's why add beam. Suppose your plate in the sense solid plate in the sense we are defining the slabs and all, no, then at that time we are selecting add plates. Okay, here add beams I'm going to select and click on that and click on finish. Then this will come, the software is open, then the default grid is closed, and then because we are coordinate we are going to select, no, right, here cantilever beam I am going to consider. This is the cantilever member. Okay, one end is fixed, another end is free. This is subjected to a point load. Okay, point load of 20 kilonewton. Okay, point load of 20 kilonewton, and the length of the AB member or length of the cantilever beam is selecting 6 meter. Okay, similarly then point load is acting at the center of the cantilever member, that is 3 meter from A to point load acting, and similarly 3 meter from the another free end. Or so consider, or cantilever member is subjected to 20 kilonewton force at a distance of 3 meter from the free end. Okay, this is our condition. Okay, so here this is the origin I am going to consider. This software is running on a or coordinates you are consider. We are going to create the nodes in Cartesian coordinate system, that is 0, 0. Here also x, y. So right here origin I am going to select A node is our 0 origin, that is 0, 0 coordinate is having. Then similarly B node or B joint is having x, y, that is 6. Okay, from here x axis is running 0, 6, like that 6, 0. Okay, right, these are the nodes. Okay, we want to select creating the node, that is first one 0, enter. Okay, then first node is created here, right? First node is created here. Then second node is I'm going to create as a 6, 0 coordinate. Okay, 6, enter. Okay, 2 coordinates are created. Okay, or 2 nodes are created. So click on the screen and then click on print view. Okay, these are the views. The front view, back view, okay, side view, okay, left side, right side view, and top view and bottom view, and it is isometric view. So I am going to select the print view because it will easy to defining everything. Okay, right, here then add beam. After defining the nodes and after creating the nodes, you have to add the beams. Okay, then click on add beam. By selecting this option, you are going to add the beams. Okay, right, similarly after adding the beam, okay, click on escape, right, then this is a geometry. Okay, this is geometrical conditions, right, then click on general. In that general, first property we have to define. Again I am going to define 450 into 450, right, then property and supports. Okay, load and definition will be there. Then property, I am going to click on property. This dialog box will come. In that we have to define the property. Okay, then we are considering the rectangular one. So rectangular, this is the depth, ZD in the sense width of the beam, and YD in the sense depth of the beam. This is the cross sectional details we are going to give define. Okay, first of all we define the we are considering the rectangular cross section of the beam. So rectangular beam is consisting of 300 millimeter width and 450 millimeter depth I am going to consider. Okay, cantilever member having cross sectional area, that is in the sense 300 millimeter width and 400 millimeter depth. This is the width, this is the depth. Width in sense ZD is our width. So that is width is 0.3 meter. Okay, width is 300 millimeter. So depth is 0.45. Okay, 450 millimeter in the sense 0.45 meter. Okay, material is concrete and rectangular safe. Okay, so click on add, then it will come. Then after creating, close it and select the node cursor. So sorry, not a node cursor, this is a beam cursor. Okay, select the beam cursor and select the beam and click on rectangular property or property of the cross section. Then next you have to assign to selected beam, then click on assign. Okay, first select the beam and select the rectangular property where defined value, then click on assign to selected beam, and after clicking on this after click assign option, then click on yes. Then this is the R1 property. So from this to this is the same material, same cross section we are going to use, right, like this. Next come to the supports. Okay, support condition like this. So in this, after clicking on support, another dialog box will come related to support. So here we have to edit, create, delete option is there. Then we have to create the support conditions. Okay, fixed support we have to provide, because cantilever member in the sense one end is fixed, another end is free. So we have to create the fixed support. So that's why click on fixed and add it. Okay, then click on support 2 is our no support in the sense S1, the S2 is the support 2. Okay, so support S2 we are not defined no support, already they exist. Okay, so only we are creating the support 2, that is support 2 in the sense fixed support. So then first the node cursor will come. After clicking on this, node cursor will come. Suppose it is not will come, then create or select the node cursor and select the node, because this node A node, this is a node, this is a B node. A node is having fixed, so fixed support. So that's why select the A node and select the fixed support in the sense support 2 and assign to selected node and assign. Click on S. This is a fixed support. This is pre end, this is fixed end. This is a cantilever member. We have defined material, the cross sectional property and support condition, and come to the load conditions and load and definition. This is very important. Okay, first one definitions in the sense snow definitions, reference load, number of options will be there. This is related to earthquake. Okay, so come to the load cases details. Click on add. Okay, next the first number, our first condition is in the primary conditions. So we have defined dead load. This is the load case is DL. Okay, this is a dead load. Okay, we are going to add, first adding the number of loading cases. Okay, one is we are in the number of loading cases in the sense one is dead load, already this we have to define, that is self weight. Then another live loads. Okay, dead load and live load you have to defining only dead load and live load. Okay, dead load is already defined, and live load only one live load is that is 20 kilonewton load. Okay, so 20 kilonewton load, it is acting at a distance of 3 meter from the pre-end or fixed end. Okay, so second case is live and define our title, given title LL. Okay, then next add it. Okay, next then auto load combination will be there and define load combination, because results will come separately, because dead load, whatever the dead load we are applying, for that what will be the bending moment, what will be the shear force will come. Okay, for live load what will be the dead for live load conditions, what will be the bending moment and what will be the shear force will come. So that's why for combination of both two, you have to give the moment and shear force. That's why I am going to defining combination of load case 3. Okay, load case 1 is dead load, load case 2 is the live load, load case 3 is the dead load. Okay, so select these two and click on this. Okay, load case 1 is multiplied with the 1 factor, and load case 2 is also multiplied with the 1 factor. Suppose you are considering dead load, 1 time of dead load plus 1.5 times of live load 2, we can select 1.5 times of live load. Okay, then like we are going to select, this is normal, this is SRSS, ABS is related to seismic analysis. So that's why we will not need to select this one. Only condition is normal general format, it is load condition into factor. Okay, so that's why this is a factor is 1 and factor is 1.5 for live load. So I am going to select. Okay, I am considering factor like this. Okay, so 1 time of dead load plus 1.5 times of live load. This load combination I am going to consider, load combination. Okay, right, load combination I am considered. So next I'll add it and okay, no, already add. Okay, right, close it. So load case, dead load, live load, load combination. Okay, I'm going to select the dead load. Okay, add, click on add. Then you have to define, this is a self weight. This force is acting in a downward direction in a negative, in a -1 in downward direction. -1 indicates downward direction, Y indicates in a vertical direction. That's it. Okay, click on add and close it. Then come to the live load condition. again click on add, then again this Analyse box will come. This is in member load, that is a member load, that is a concentrated point load. Okay, then in previous video we did some mistake. We are providing the positive value, but it is we have to provide in negative value. This is a minus 20 kilonewton load acting, in the sense 20 kilonewton is acting in downward direction, that is minus 20 you have to define. Okay, in previous video only we are providing 20, then next we will change. Okay, ಆಮೇಲೆ ಚೇಂಜ್ ಮಾಡಿದ್ವಲ್ಲ, ಸೊ ಇವಾಗ ನಾನು ಏನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ, minus 20 ಪ್ರೊವೈಡ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ, that is minus 20. Minus indicates the load is acting in downward direction. 20 is a point concentrated load in kilonewton. So right here D1 value is there. ಓಕೆ, ನಾವೇನು ಮಾಡಿದ್ವಿ, ಸೊ ಇಲ್ಲಿ D2ನ ನಾವೇನು ಮಾಡ್ತಾ ಇದ್ದೀವಿ 0 ಅಂತ ಪ್ರೊವೈಡ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ, D1ನ ಏನು 3 ಮೀಟರ್ ಅಂತ ಪ್ರೊವೈಡ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಸೊ D1 is 3 ಮೀಟರ್. ಓಕೆ, ಸಿಮಿಲರ್ಲಿ GY, okay, click on add, close it. Okay, we'll change node, we'll see what will happen. Okay, right, then you have to these are the defined values, you have to assign this. Okay, before going to assign, then select the beam. Self weight is for throughout the member. Okay, then self weight, select, assign to selected beams, assign, click on S, then load 1 will come at the bottom. Okay, similarly come to the live load conditions. Okay, live load, okay, selected this, for this beam only you have to assign, no, that's why select, already selected, and concentrated point load of 20 kilonewton 0 to 3. So assign to selected beams, assign yes. Okay, point load is acting at the center. This is from 0 to 3 meter, this is 0 to 3 meter. Then load combination you have to not already auto combination will give, it is already assigned, so there is no need to apply. Okay, then already, because ನಾವೇನು ಮಾಡ್ತಾ ಇದ್ವಿ, ಇದನ್ನು ಸೆಲೆಕ್ಟ್ ಮಾಡಿದಾದ್ಮೇಲೆ ಇದನ್ನು ಸೆಲೆಕ್ಟ್ ಮಾಡ್ತಾ ಇದ್ವಿ, ಆಲ್ರೆಡಿ ಎರಡು ಸೆಲೆಕ್ಟ್ ಆಗಿದ್ದಾವೆ ಅಂತಂದರೆ ಇಲ್ಲಿ ಅಸೈನ್ ಟು ಸೆಲೆಕ್ಟೆಡ್ ಬೀಮ್ ಬರ್ತಾ ಇಲ್ಲ ಅಂತಂದರೆ ಅದು ಆಲ್ರೆಡಿ ಅಸೈನ್ ಆಗಿದೆ ಅಂತ ಅರ್ಥ. ಓಕೆ, ರೈಟ್, ನೆಕ್ಸ್ಟು ಪ್ರಾಪರ್ಟಿ ಆದಮೇಲೆ ಸಪೋರ್ಟಿಗೆ ಬರ್ತಾ ಇದ್ದೀನಿ. ಸೊ ಸಪೋರ್ಟ್ ಆಯಿತು, ಲೋಡ್ ಕಾಂಬಿನೇಷನ್ ಆಯಿತು, ಸೊ ಮಟೀರಿಯಲ್ ಆಲ್ರೆಡಿ ಕಾಂಕ್ರೀಟ್ ಅಂತ ಡಿಫೈನ್ ಮಾಡ್ಕೊಂಡಿದ್ದೀವಿ. ಸೊ ನೆಕ್ಸ್ಟ್ ಕಮ್ ಟು ದಿ ಅನಲೈಸಿಸ್ ಪ್ರಿಂಟ್. ಓಕೆ, ದೆನ್ ಕ್ಲಿಕ್ ಆನ್ ಆಲ್ ಆ್ಯಂಡ್ ಆ್ಯಡ್, ಕ್ಲೋಸ್ ಇಟ್, ದೆನ್ ಗೋ ಟು ದಿ ಅನಲೈಸಿಸ್, run analysis, save, then already analysis is over, then go to post processing mode, done, and load combination is there. Okay, apply, click on apply and okay. Okay, then each and every, see here, dead load, for dead load what will be the bending moment, for live load what will be the bending moment. Okay, the for load combination what will be the bending moment, point load, and this is a point. Okay, then right, next this is the displacement. Okay, only you have to represent the displacement like this. So then for shear force diagram, Fy, okay, this is the shear force. Okay, so next these conditions, these are the shear force, bending moment. Okay, mz for envelope, this is for load combinations ಗೆ ನಮಗೇನು ಬರುತ್ತೆ, mz ಈ ಥರ ಬರುತ್ತೆ. ಸೊ ನೆಕ್ಸ್ಟು fz ಬರಲ್ಲ, ಸೊ fy ಈ ಥರ ಬರುತ್ತೆ. ಸೊ ದೀಸ್ ಆರ್ ದಿ ವ್ಯಾಲ್ಯೂಸ್. ಓಕೆ, ಆಲ್ಸೋ ರಿಯಾಕ್ಷನ್ಸ್, ಕ್ಲಿಕ್ ಆನ್ ರಿಯಾಕ್ಷನ್ಸ್. ಓಕೆ, 49.085 kilonewton, z, mx, my, mz. Okay, mz in the sense moment value, kilonewton meter, 147.255 kilonewton meter, this is 49.085 kilonewton. Okay, why? These are, this is the shear force value, this is the bending moment value. Okay, then displacement, reactions, report will come. Okay, beam, once again, beam, then right, 1 second. Okay, right, here animation, node option, beam option is there. After selecting the beam option, here forces, this gives the force values. Okay, this gives the stresses values. Okay, right, then it graphs in the sense what, here 147 is the, this is the cantilever beam graphs, beam 1. Okay, this is the bending moment, these are the dimensions, mz, this is the bending moment diagram, this is shear force diagram, and right, these are the conditions like this. Okay, this graphs, stresses, forces. Okay, then beams like this. Okay, reports will come also, then select all these conditions and click on OK, it will give the report related to that. Okay, so right, beam, this is the condition. Okay,